start with number 9. So number 9, I already kind of did a factor tree here. We are trying to find what can make this negative 16. Now with this one, we should be finding that this is where we see a 4 times a 4 times a negative 1 can get us that negative 16. So, by splitting it up, we'll first split it up so we can kind of see the separation here. Now, that 16 can be a 4 times a negative 1. And I'm already going to split these two into this way, so it's kind of more simpler to do. And that same method, we found a pair, we pull that pair out. We're left with the negative 1 under the square root. Then we are given x of 2 over 2 times y of 8 over 2. These can be simplified. So the x, that's just x to the 1, and y to the 4th. Now you can see that this is not in any of the answers, and that is because 4i is the same thing. So then we are left with 4i x y to the 4th, which you'll see is answer C. All right, for number 10, 30, we're going to just separate it. That's just what I do. So you, sometimes it's clearer to see what you are separating. And 36 can be turned into 6 times 6. This is the same as we remember to the half, right? We found that pair, we take it out, so we have a 6. And this is the same as 8 over 2 and y to the half. Now we can simplify this once more, which we do see this as an answer right over on A. All right, for number 11, again, we are splitting up the 64, and we see we need to find cube roots. So that is where we see that negative 64 is the same, right? Make sure we add a 3. Make sure we know we are separating it into... Right, a negative 64 is the same as a 4 times negative 4, right? Or it can even be negative 4 times negative 4 times negative 4, right? Because it's an odd value. Times, let's write this back. So we have our 7 to the 3rd, right? And then we have our y 12 to the 3rd. Then that could be simplified to 7 over 3 and 12 over 3. Now, because we see that's the same value, right? So we see there's 3 negative 4, so we can bring out that negative 4. And x to the 7/3 is how simplified as it can get. And our 12 over 3 can also become a 4. So you should be able to see for number 11, our answer is A. Now, for 12, we are trying to find groups of 4, right? So we're going to split up that 81, which I did over here, into 4 threes. That was what we found using that factor tree method. So we see that 81 is the same as 3 times 3 times 3 times 3, right? And we're still having that 8, right? And y to the 12th. And same thing, right? Of 8 over 4 and 12 over 4, right? Now we find those groups. So there are 4 threes. So we take out that 3, remember, stays out of the radical. And we simplify the rest. And we should see the answer right on. Now, 13 is something I believe you're not going to really use on the test, but it's a good way to figure out how to manipulate the numbers to where it's easier to do. So a way to do this is we can see that 9 is 3 squared. So this value, this 9, 5 over 2, is the same, basically, as 3 squared to that 5 over 2. Because 3 squared is 9, right? And when we simplify that into the next, we have 3, right? When you have this happen, you're doing 2 times the 5 over 2. If we remember that property there. Now that simplifies to 10 over 2, which we can do it over here if that's something that multiplying fractions, I understand. So it could be you only multiply the top, right? Because that's the same as 2 over 1. So we have 2 times 5 is 10, 1 times 2 is 2, and that's how you get that 5 when we simplify. So you can either keep it as that. It's basically what they tell you if they say, hey, give me it as a number, or you can have exponents in there. If you're not allowed exponents, I definitely would try to multiply that out. So you can have either of these as your answer for number 13. Now, number 14 is something interesting. For this one, I would say try to put it into better understandings, if that makes sense. So this can be also, if we remember our properties that we've been learning, that is the same thing, right? And this is also the same thing here. As we remember our properties of how this can equal the same thing. These two are equal. And we've already kind of proved those, and we've seen examples of it. Now, through there, you can have the radical under 5 with 729 once you multiply this out. You get 729. And that is why I have a factor tree of 729. And you can see you're trying to find 5 groups or 5 of something in here. And that is where you see there's at least 5, right? So from there, there's actually 6 3s, which you will see how we need to split those up. 1, 2, 3, 4, 5, and 6, right? That equals the same thing. And we're trying to bring out groups of 5. So this is that first group of 5. And we take that 3 out, if we remember those steps. And we are left with that regular 3 under there. So that is the most simplified version of this. 3 cannot be broken down any smaller. So that is where we get our final answer for number 14. I hope this at least kind of helped on some of those problems. I do know I did give you the numbers, so you need to make sure you know 1 through 5, 7, 10, and 12, and I put it in the announcement too. As long as you knew how to do those, and if you need help on those, please let me know. Those are the kind of basics. The rest are kind of just challenging ones, just kind of get some practice. But those 1 through 5, 7, 10, and 12 are core things that you'll need to know